This conference will now be recorded.
Hi everyone, let's start the session. So I hope everyone able to hear me. Can you please someone confirm? Am I audible to
Yeah,
you all?
yeah,
Okay, good. Thanks. Yeah. So let me give brief idea about the intention of the today's session before I proceed. No, the main intention of the today's session is so to know the what is exactly Spark, why people are talking about that, and if we want to explore the Spark, like what knowledge we need to have it, and what are the things we are going to covering as part of this course. That's what primarily I'll be going to talk in this session. And I want to make this session is more interactive, not like a one way. So whenever you feel like what you have some question, please raise your hand and you can ask me the question and unmute yourself. You can or else put in the chat box also. I'll be frequently verifying the chat. No, I'll be going to answer. Or else you can unmute yourself. You can feel free to ask. It's not like end of the session only you have to ask. Not like this. Make this session are always interactive. My class will be always like that only. And this session also, I want to take it same way now. So that way, like what you will get a feel like what's happening whenever I'm discussing. Hope all are clear on that point now. Okay. So the first thing is like what people who are interested to go for this Spark course now. The first prerequisite is like what basic knowledge on the Hadoop course is required now. The main technologies like what Hadoop. So what is Hadoop? Under that like what HDFS, MapReduce, Yarn. What are exactly those are talking about now? Then after that ecosystems of the Hadoop primarily, which is right now people are all are using it like what Hive. Hive is the mandatory, and then after that like what NoSQLs as part of the NoSQL like what all the NoSQLs is not mandatory, but main NoSQL is like what HBase you should be familiar based on the company requirement like what people might have a knowledge on Cassandra, MongoDB also well and good. So these are the first primary things like what you need to, and along with like what streaming technologies, maybe if not have it also not a problem. As part of this Spark course like what we'll be going to talk about streaming technologies with streaming integration, but at least that much whatever I explained like what till that is like what primary knowledge like what you need from Hadoop course now. Okay, I hope everyone have that knowledge. I'm assuming if not, we can still continue this course now, but make sure that like what build that knowledge and going for the Spark course like what makes sense. Why? Because when you go for Spark interview or Spark job like what you're not only going to work on the Spark, you will work with the Hadoop with the Spark now. So that's the reason like what Hadoop knowledge also mandatory. Is that everyone is clear that statement now?
yeah.
Okay, good. Now let's talk about like what Spark now. So coming to the Spark, like what, why it is started and who is started now, and why we need to go for Spark also. That means there might be some existing systems having some problem now. That's the reason we are going for Spark now. So that much knowledge, because most of the people will think like what Spark we are going is the main reason is because of like what performance. If I go with like what traditional big data systems, it is taking time. No, Spark will give you things in a faster. So that is valid statement, but that's not the primary reason now. Okay, so this session will give you the answer for like what why should I go for Spark now. Okay, at least till that much I'll be going to take it now. Okay, let's start with the history of the big data and what is big data as a high level. Let me explain, because already people who learn the Hadoop course know they know it, but just we need to recollect it like what to connect our points now. First thing is big data. So what big data is talks about like what primary three V's: volume, velocity, variety. Okay, is not only these three V's. Now we have vulnerability and value of the data. Like this, so many other things. No veracity like this, but main three V's are like what volume, velocity, variety. And with these three V's, what big data is pointing like what there are two primary problems. One is storage problem. Second one is processing problems. So what are the solutions you are learning in this big data courses like what? Mainly these two solutions only. One is storage solution, second one is processing solution. There are two problems are pointing big data, storage and processing. And coming to Hadoop, so Hadoop provided a solution for like what this both storage as well as processing. In big data, which is the primary solution like what giving for both storage and processing is like what only Hadoop. Nothing else is there now. Maybe other solutions, whatever you pick, maybe like what those are storage solutions or maybe processing solutions or combination with some challenges. But when it comes to Hadoop, like what not, that's the base solution, and always people are going with that. Why? Because like what when you want to store terabytes, petabytes, exabytes, zettabytes of the data, also you can store it. There is no restriction on like what variety of the data also. Okay, it can be a structured, semi-structured, unstructured format also. We can able to store the data in HDFS. But what is exactly challenge in Hadoop like what map reduce? So what is the problem with the map reduce like what? Map reduce is a disk level processing. In older days like what it is okay, but nowadays this solution is not good. Why? Because like what we have enough memories are available in every system now. In older days like what RAM is very less. Okay, but nowadays we have very good amount of RAM now. Can you please someone tell me like what how much RAM we are using it nowadays? What is the RAM capacities?
8 GB.
This is a very important point you all need to remember exactly. Yeah, how much RAMs we are using it?
16 GB.
16 GB.
8
Okay,
GB.
8 GB. These are in our personal laptops now. Okay, how about like what in company servers? Any idea by anyone? Okay, fine, let me give the answer. Okay, so in older days, like what we used to have the RAMs are like a MBs, then MBs are turned into a GBs. Okay, and now those GBs are turned into a terabytes. Okay, so it's not only gigabytes, the RAM capacity, not only gigabytes, terabytes, 1 TB, 2 TB, 4 TB RAMs. The RAM capacities are like what? That much. When it come to hard disk also like what? Initial days is a MBs, and they went to now gigabytes to terabytes also we are using in laptops. But when you go for systems like company servers like what, they also having a support of like what petabytes also. Okay, so why I want to bring this point is like what you have terabytes, petabytes of the hard disk and the RAMs are there like what still your application is builded on like what only hard disk level, not utilizing the RAM. So that is not right solution. Okay, so that's the reason like what industry expecting the solutions on the RAM almost from last 10 years, almost from last 10 years like what people who are building the applications on big data and non big data also, most of the people what they are concentrating like what in memory solutions, not the disk level. Disk level is a traditional approach now. Okay, so what is exactly people are expecting a solution is in memory computation. Utilize your RAM as much as what you have it now. Okay, and try to process it in a short time. So that's the primary goal of like what current solutions like what in big data or non big data also, like ETL applications or BI applications, whatever we have it also, database everywhere. Everywhere this trendy concept is there now. So that is a one primary reason. When it comes to that, map reduce is not the right design. It's an outdated design now. So map reduce like what disk level processing. If you are having more disk, you want to utilize that, good. But if you have more RAM also using MapReduce, you won't get better performance. People want that. So that is the main problem with the MapReduce. And one more problem is like what you need to write in a Java. So you should be expertise in Java, and the length of the code is like what very heavy. If you want to write simple hello world program in MapReduce also, at least you need to end up with like what 80 to 90 lines of the code now. So it's very lengthy code now. Okay, so if the lengthy code means like what, it will be more time taken like what to develop it, and if any issue is coming also to identify also, it takes some time now. So these are the challenges now. Okay, along with this there are some more now, I'll come there. And other component of Hadoop, what we have it market like what yarn. There is no problem with the yarn is the market leader. Okay, already from like what last 8 years he is the market leader, and today also like what he is the market leader. There is no replacement for yarn right now. There are so many alternatives are came already, they went off in the last 2 years now. Some of the alternatives are like what they completely shut down also. So yarn is the market leader. What is the purpose of this yarn is like what resource management. You have some task is there and you want to execute that task by utilizing your resource like what yarn says like what, yes, I can do it for you. It's a completely flexible component like what anyone, any type of project like what they can use it now. Hadoop right now, why people are using it like what, the primary reason is SDFS, and second reason is like what yarn, and the framework of MapReduce. Not writing a code in the MapReduce now. People are not writing a code in a MapReduce. Then what they are doing? So when it comes to that question like what, alternative answer is like what, ecosystems. Hadoop build, there are so many ecosystems now. Okay, so in that ecosystems like what they have categorized into a different things like SQL wise, streaming aspect wise, machine learning wise, and graph theory wise. Like there are different kind of like what solutions are built on top of the Hadoop. So most of them like what they build as on top of the Hadoop. Some of them they build like what alternative to Hadoop also with respect to processing, primarily with respect to processing wise now. Okay, if you are going for MapReduce, you should write a Java code. I'm not interested to write a Java code. Then I'm interested to go for like what, SQL queries. I want to create a table, insert the data, retrieve the data, everything in SQL style, not in a Java program. Then you can go for like what, these are the wide variety of choices like what you can go for Hive, Impala, Drill, Phoenix, Kudu, Cassandra, like this. There are so many SQL favors are like what available in the market now. Main thing is, instead of writing things in a Java, you want to solve the problem in a SQL. That's the only thing here now. Okay, like that only some streaming solutions also. I'm getting like what, real-time data. I'm getting like what, real-time data. Examples like Facebook streams or YouTube streams or maybe Amazon, Netflix, like what. So people are like what, watching some videos now. The streams will be like what they are watching it now, at what time they watch that for now. So are they interested on this particular scene or not? So based on that, they can give some kind of suggestions also. Okay, so they can give that kind of things they want to do. It means they have to collect the data in a real-time fashion, maybe ATM transaction or online transactions, whatever we do, buying or selling something, or maybe like anything. So which kind of real-time messaging in WhatsApp, Telegram, like everything is comes under like what, streaming concept. Under the streaming like what, there are certain solutions are already available in the market like what, Flume, Kafka, Storm, Chukwa, Scribe, like this like what, there are certain solutions are there. Most of these solutions are built as an alternative to MapReduce. Why? Because MapReduce design is not meant for streaming. So these are primarily built like what, alternative to MapReduce. Okay, so these are all on top of like what, some of them like what having integration to MapReduce is there, but some are like what, directly alternative now. Okay, so from 2009 onwards like what, these solutions are available in the market. And along with these, people from like what data science world, okay, who are working as a data scientist, machine learning technologies who are using like what for them also like what there are some machine learning technologies are there. They also meant for processing, but they cannot process large amount of data. Then if you integrate with Hadoop, like what it is possible, okay, I can integrate Python with Hadoop, R with Hadoop now. So not only with Java, mainly like our main code is like what Hadoop is Java, but still it also supports like what other flavors of the Hadoop is like what we can do coding in R, Python, .NET, Ruby, other programming languages also integration is there now. So those integrations like what mainly machine learning people, they are utilizing it now. Okay, other than machine learning is like what graph theory in social media, like what this one, and also like what Uber, Ola, these cabs also like what they are using the this graph theory technology. Okay, so here also like what some of them are like what on top of Hadoop is there, or some are like what parallel to Hadoop also. So mainly what is the intention I want to bring here is like what Hadoop is the base for most of the technologies what we are using it, but the challenge in Hadoop is like what MapReduce. Okay, MapReduce is not capable to do everything like SQL, streaming, machine learning, graphics, all these things. Okay, so people are expecting some better replacement or alternative for MapReduce. That is what people are saying nowadays is like what Spark. But before we go for Spark now, at least is everyone is clear the problem here now. What is exactly problem with Hadoop? Any question on that?
Yeah, yes, sir.
Good. Okay. So if there is no question, let's continue. So now what type of problem we can solve with this Hadoop solution also? First, let's see. And the same problem with like what with Spark also, is it possible also? Let's see. First thing is utilizing this design Hadoop and all these technologies like what, suppose there is a requirement for me. Okay, so what the requirement is, I need to collect the real-time streaming data. With the help of the streaming technologies I can collect it, but the problem with the streaming technologies like what, they only collect the data, they give it to someone, they don't have any permanent storage. Any streaming technologies you go, temporary storage is there, permanent storage is not there now. Okay, that's the main design of the streaming now. They collect the data and give it to someone, just like a courier boy. And suppose I have like what some social media data is there, maybe elections campaign. Okay, so in social media like what people are like what posted some things and people are given comments on that, likes on that, dislikes on that, I want to capture that information. So with the help of like the streaming technologies like what, we can capture the data, and whatever the data I have captured, I can push it to the Hadoop. Hadoop handle all varieties of the data. No, I can push it to the Hadoop. Then after that, like what, I want to clean the data. I want to clean the data like what, by integrating with this SQL technologies like what Hive or Impala, Phoenix or Kudu, whatever it may be. I can integrate with Hadoop now. Then I can read the data. I can clean the data again. Whatever the data I cleaned it now, I want to write it back to the Hadoop now. Again, I can write it now. Okay. And after that, whatever the clean data is there, I want to analyze that. So what people are talking about now, some sentiment analysis on that. Okay, and the user level like what recommendations, no, anything I want to do it now using machine learning like what, I can do it. So this will generate the output now. It understand the data, it generates some output now. That output, they're the programming languages, most of them. Okay, so they don't have any storage, it's just a language. So you need to store the data into Hadoop back now. Again, we can store it now, and whatever that result I got it now, if I want to find a relation between the people who posted now, is a friend of other one or not, like what, are they belongs to the same location or not, I want to identify that. So that information using graph theory I can do it. Again, these systems also directly they don't store it now, they good to store it with like what, hard. So in this approach, what exactly happening, we're getting some data, we're storing here, we're cleaning the data, we are storing here, we are analyzing the data, storing here, and finally we are finding some relation, storing here now. So what is happening here is like what our primary connectivity for all these things, we are going for Hadoop. The reason is the streaming doesn't know how to talk to SQL, this SQL doesn't know how to talk to machine learning graphics like this. They don't know each other. All of them know like what Hadoop. All of them know like a Hadoop. So using Hadoop, we are able to solve that problem now. But there are certain challenges are there. What are those challenges here is like what? If something went wrong here, if something went wrong in the streaming part, like what this SQL, machine learning, graphics, they don't know. Only who knows like what? Hadoop. So in Hadoop, we are using for like what storage purpose means like what the storage system like what will write the data or won't write the data. If the data is coming to write, otherwise it won't write. If something wrong means like what it just have the only till what time it is written only. The other information like what he's failed or not, that information it cannot write. Okay, so that is a challenge here now. And a coding point of view, if you look at also like what these streaming technologies, maybe you will do it in a Java or Scala or Python, some language you will choose. And here is like what SQL style. In Python also, it's machine learning also Python, different other programming languages now. And graph theory like what mainly C++ and Java and Python. These are three programming languages mostly people are supported now. So what is exactly one more point, if you observe it now, multiple programming languages are involved, or some of them may work on only Windows, some of them may work on only Linux like that. Okay, some platform dependency is there, programming level dependency also there now. And the code wise, sometimes it is very lengthy code. If you do some coding in like what Java, it might be very lengthy. Same code can be in Python like what it might be small also. It depends on the programming language also like what it will vary, maybe if you write a MapReduce program 100 lines, same MapReduce program if you do it in Hive like what one line of SQL query, so it's 100 lines equal to 1. So it depends now the length of the code also like what it will differ now. So like this there are different things. Finally main problem is all are going with the disk level processing. All are going with the disk level processing. Because of that I can't gain the my in-memory utilization now. So things will be like what very slow. If I compromise on other points also, still my execution time will be taking more because of like what disk level processing. So what is industry expecting right now, like what if anyone can solve these problems, whatever I explained till now, okay, if anyone can able to solve this problem in a simplified manner, they can go for that. So that is a place only like what Spark enter into the picture now, and entire market is why turn into that one is like what main reason is that. Okay, so before I explain the Spark now, hope all are clear with the existing technology wise problems now. Whatever I mentioned now Spark is solving or not, I'll be going to discuss now. But is that points are clear to everyone?
Yeah.
Okay, good. Now let's talk about like what Spark now. So how exactly Spark entered in the market now? Is it intentionally developed or who developed and all those things? Let me give some brief idea about that. So Spark is not developed intentionally. It is started unintentionally by some people now, and now Spark is becoming as a market leader. And who started this one is like what? In 2008. In 2008, UC Berkeley University like what? There are some students like what, so they did some project on the resource management. I'm talking about 2008. Okay, and people you already know from Hadoop there's a concept called yarn. This yarn is started implementing from 2009 onwards. It is released on 2013. Okay, so before yarn only what we are talking about this. Okay, in 2008 there is a project is started. What is that project name is like what? Mesos. In 2008 there is a project called Mesos is started in UC Berkeley University by some students. The main goal of that project is like what? Resource management. At that particular time 2008 we have Hadoop is there. Okay, Hadoop, HDFS and MapReduce. Yarn is not there. Only HDFS, MapReduce. And they know what is exactly drawback of the MapReduce. What challenges is there now. So they taken that is a baseline now, and they started implementing the Mesos project now. What are the drawbacks in the Hadoop resource management side is there now. Those challenges are like what addressed by the Mesos project in 2008. They started, and in 2009 now they have a question now. Okay, we want to test whatever the project we implemented. First they tested with a Hadoop. First they tested with a Hadoop. Whatever the baseline they have taken now, they tested with Hadoop. It is fine, but still they are not happy with that. Why? Because whatever the resource management they implemented now, not only for batch processing, for iterative and real time, these type of like what other type of projects also they want to test it at that particular time. Like what these projects are not there in the market. Whatever this Flume, Kafka, like what they started from 2009 later now, 10, 11, 12, like this now. Okay, but our journey is like what at the time of 2009. So at that time there is no well-known project apart from Hadoop now. So now they have a question like what? How to test our project completely end to end. They don't have an answer at that time. Then what they decided like what? Why don't we implement some test project? Why don't we implement some test project, and then after that like what test our project. Their main goal is only Mesos to test it only. Okay, so obviously like what whatever the test project they want to build it like what within a short time, within a small code, like what they want to build it now. And in that case like what they have taken Hadoop is the base project now. On top of Hadoop they started now what is that project here calling as a Spark. In 2009 Spark is started now on top of the Hadoop. People might think like what Spark is different. Not. Okay, just a second. Sorry. Yeah, so people might think like what Spark is a different. It's not. Spark is completely built on top of the Hadoop at the time of 2009, and the initial code of the Spark is like what just 1,000 lines. Just 1,000 lines of code. Spark, whatever the Spark project they built now at the time of 2009, just 1,000 lines of code only. The reason behind the code is very less is like what they use the one of the programming languages Scala. Scala is developed on top of the Java. Okay, so if you write some Java code, maybe like what 100 lines, sometimes that 100 lines of Java code can do it in a Scala like what maybe in a 50 lines also. It's a very concise code now. Comparatively Java, it's like what user friendly way of writing will be there, concise code now. So that's the reason like what whatever they implemented using Scala, like what the code is very minimal. If they do it in Java like what it might end up with a 5,000 or maybe 10,000 lines now. But they did in Scala, it minified version was. Okay, and then they started testing with like what Mesos, then they are fine. And what is exactly one more important thing here is like what whatever the Spark project they implemented with this 1,000 lines of code, they run that Spark project like what for a particular task. Okay, and they are able to observe like what things are executing faster than MapReduce. How much exactly like what the Spark is 10 times. The Spark initial version of the Spark, the just 1,000 lines whatever we're talking about, it is 10 times faster than the MapReduce. At the time of 2009 it is 10 times faster than the MapReduce. Then these people like what mind is shifted from Mesos to Spark now. From there onwards like what their mind is shifted from like what Mesos to Spark. Then they started the journey of the Spark now. Spark is not started intentionally. How it is started like what as a testing project, as a testing project for like what Mesos now. But now Mesos is not there in the market, Spark is there in the market now. So hope everyone is clear now. why Spark is started, and what is the reason behind that. Is all are clear? First initial point now. Okay. Yeah. Now coming to the journey of the Spark, when we see like what, as I said, 2009 is the journey is started now, and the initial stable version of the Spark is like what, around 2013. Around 2013, like what, the Spark, okay, moved to the Apache. Till that time it's just a Spark, it's not Apache Spark now. Okay, so it is moved to the Apache. Then after that, like what, people has to contribute to the Spark now, then only like what, that will becoming as the part of the Apache now. Otherwise, it will go to a dead project now. But what is interesting thing, like what, most of the people like what, started contributing to the Spark than Hadoop now. Than Hadoop now, because they already observed now. Okay, it is better than the MapReduce. People are already struggling with like what, MapReduce, like what, lengthy code and in-memory computation is not there now. Then they started shifting like what, their execution, everything like what, slowly development aspect, everything like what, Spark now. Okay, so around 2014 July or like that, like what, so this Spark is becoming like what, top level project of Apache now. And from there onwards, like what, people 100%, if any project is part of Apache in a top level, means like what, people can accept that they can start utilizing it now. So there are three stages will be there in Apache. One is incubator state, that is the initial stage now. Any project can enter into an incubator state, and they keep in observation now. Once this observations things are, everything is fine now, they move it from incubator state to top level projects now. And there people can use all this all that projects now. Then suppose if there is no contribution to that project, the project is like what, becoming outdated now, then it go to a retired stage, attic stage. There is a concept called attic. There are three level of stages will be there. Okay, right now Spark is under like what, top level projects now. And it's a top level project, people can able to utilize that. Around 2014 onwards, like what, Spark becoming as a top level project now, and most of the people like what, started using it now. So that's the history behind that. And competition wise, and also like what, why most of them are turned into the Spark is like what, when it is happening is 2016 onwards. 2016 onwards, the main reason is like what, in 2016 January 1st, 2016 January 1st, so the first certification of the Hadoop and Spark is entered in the market. Before, till before like what, 2016 now. Okay, it's only Hadoop certification is, people are not much worried about like Spark. But from 2016 onwards, like what, the certification is like what, Hadoop and Spark now. Not only Hadoop now. Okay, Hadoop and Spark also required industry. It is forced exactly. Then there onwards, like what, almost every company and people also like what, started learning in depth of the Spark now. Coming to my course also, like what, I started in Spark course in Orienit is like what, 2016 January 1st. On that day only I have started my Spark course now. And also that certification, what I am talking about, Spark with Hadoop certification. So Cloudera CCA 175 certification. So that is the also like what, started on that day only. I am the first person throughout the world who cleared that certification. So January 2nd 2016, I am the first person. And entire month of the January, like what, only around like what, 10 15 people are only cleared now. So you can check that list in their website now, that information will be there now. Okay, why I'm pointing that time, like what, Spark people are like what, at that time is very less people are having the knowledge now. Okay, now almost everyone using it. Almost 2016 now means like 7 years now. Okay, most of the people already in every company Spark is using now. So Spark is the mandatory. That's the reason like what, why all are coming for the Spark now. Hope everyone is clear the intention now. Why we need to go for Spark is like what I had to cover now. But the reason behind is like what, all technologies has to like what, migrate to the Spark, because of one of the primary reason is like what, fastness. That's what is like what all are no. Other than that, what are the problems I explained previously, those also I'll cover with the specifically. But at least till this point, any questions before I go with the actual reason to go for Spark now? Okay, good. So now whatever the slide I have shown here now I have built similar slide for like what Spark now. This is for Hadoop, this is for Spark now. Okay, so what is the primary thing difference between these two? Like what here we are having a Spark, and in Spark primary component is called as a Spark core. This is the heart of the Spark now. Completely Spark based libraries, everything will be like what in Spark core. On top of the Spark core, it is supporting 4 libraries. These are the official libraries now. Okay, Spark core, on top of that Spark SQL, Spark streaming, Spark MLlib, Spark graphics. These are the 4 official libraries are available now. And the Spark supports like what officially there are 4 programming languages: Java, Scala, Python, R, and also like what SQL wise like what PLSQL support also we have it now. Unofficially .NET, other programming language support also, but officially these are the 4 programming language support along with the SQL now. So this is what like what Spark, what exactly it's supporting. Spark core is the primary on top of the 4 libraries, and also programming languages wise also like what 4 variety of the programming language: Java, Scala, Python, R, and also it supports like what SQL. Okay, so in this coming to the Scala, Scala is the mother language for Spark now. So completely Spark is developed on the 90% of the code in Spark is developed is only on the Scala. But to support the other programming languages like Java, Python, or other things like what, so around 10% of the other code is like what they build now. So if you are going for Python, that's what people will call it as a PySpark now. Okay, if you are going with R, Spark R now. Okay, if you are going with SQL, Spark SQL. Okay, so these are all like what some extra enhancements like what they did with like what other part of the coding now. But mainly the main part of the code Spark is implemented on the Scala. If you want to add any new features, if you want to enhance existing features like what, you should develop on the Scala only. Okay, using Python or R or SQL, you can't build your own features on the Spark now. That's not possible. But why people are talking about, maybe most of the people might be saying like what PySpark. Okay, can someone tell me from your point of view why people are saying PySpark, 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 Spark with Scala, and the PySpark? There are 2 things people are discussing, correct? And some people are saying like what, when you're learning Spark means like what, learn PySpark. Some people will say, learn. Some people will say Spark with Scala. So can anyone tell me why people are saying PySpark now? Anyone knows the reason?
Python is a little bit easy to write than Scala.
PySpark is easy to write.
Yeah,
Okay. What about others?
it's more readable than
More readable. Any other answers from anyone else? Okay, fine. Let me tell you. So, what he's saying, like what more readable and more easy to write, that's valid, but it is not only that exactly. Okay, so the history, if you see it like what, just to get an idea, I'm just saying this one now. The Java and Python, these are the 2 programming language like what everyone nowadays they are hearing now. But in initial programming language is the Python. Later Java entered the market and completely it swapped the Python almost till 2007 and 8, like what people not even talked about anyone like what Python now. There is a programming language is there, people are using it now, it's good, but not even talked about. Okay, so when exactly this Java is acquired by Oracle? Java is acquired by Oracle around, I think, 2008. I think they acquired now. Okay, so when acquisition happened, like what most of the features of the Java, they stopped it almost from 2008, then around 2016 or 17, like that also, like what almost like what Java is no much changes now. There are some things, but not that much. At this particular time only, the big data world, the dates, the years, why I'm discussing so many times, like what to relate this one only. The big data journey, everything you observe now, 2008, 2009, these years only. Okay, so at that particular time, like what industry need? So one is object oriented programming language. Second one is like what functional oriented programming language. They need two variety of the programming languages now. Okay, so Java is entered in the market in a style of like what object oriented now. Okay, the design completely like what object oriented features now. But Python and R, these are like what functional oriented. These programming languages are like what by design initially. Okay, these are in a functional oriented. So many inbuilt functions will be there. So why he is saying like what easy to write? The main reason is this only. Suppose I want to calculate like what product of A and B. A is a matrix, B is a matrix. Now in Java I need to write a code. In Python you just use some inbuilt library function like what that will solve for you. You don't need to. There are so many statistical mathematical functions are like what available in this Python and R. Exactly these programming languages, they build mainly for that purpose. Mainly they build that for not for like what object oriented problem to solve now. Okay, but when big data world is entered, like a what and the statistical data analytics part, this data analytics part is come entered the market, like what this Python and R, again they came back. Okay, they came back now. At that particular time is like what almost Java is in a not in a shape now, not in a shape. Okay, I'm talking about in a specific duration now, not today. Okay, so almost in that similar time only, like what we also need to think about the Spark main implementation, what we said Scala. I'll talk about in our main course now, the history behind all these things now. The Scala is also like what it is both object oriented as well as functional oriented. Scala when it comes to like what both object oriented as well as functional oriented. But the main problem here is like what Scala is implemented on the Java. In Java, it's not. It's a functional oriented. It is mainly object oriented. So functional. So they build in Scala like with that functional style now. But most of the functions what Python and R is there, like what not available in Scala. Not available in Scala. So that means if something I want to build like what little, it is little time taken. Maybe this statement will be go away in a few years now. But right now this problem is there now. So that is the one reason like what people who are in a data science world, who deal with the data analytics, mainly with statistical operations no machine learning techniques no, so they primarily go with like what Spark with Python or R. They don't worry about like what Scala. But people who are in a application development aspect now, okay, so I want to build my application like what in an object oriented style now, object oriented style, and also like what utilizing the my logic in a design battery, everything like what I want to utilize in that way, like what they go with like what Spark with Scala, not Spark with Python. So that's the difference. So data engineering and data science, there are two things here now, data analytics, data engineering. So data engineering part, like what who are mainly they are doing like what they go with the Spark with Scala, data science aspect, data analytics aspect, who are going like what, Spark with the Python. So that is the main difference. But the problem, as I clearly mentioned, like what, if any new feature you want to add, you cannot do with Spark with Python. You have to do with Spark with Scala only. The mother language of Spark is like what, Scala. So that means data analytics. What is the goal of data analytics now? There is a problem, utilize some existing functions, solve it, not to reinvent something now. Okay, but data engineering concept is not like this. Data engineering concept is like what, some feature is there, some other feature is not there, you have to add it, you have to add that feature. That is a place like what, data engineering part will come now. Okay, there Scala importance will be there now. Hope everyone is clear now, which one people will use, what purpose, and what limitations are there. Is all are clear on that? Okay, and one more interesting things like what, people who want to learn this programming languages like what, easy to learn Python. Learning the Python basics are very easy. Okay, so comparatively Java, but this statement not valid nowadays. These are all I'm saying like what, in a early days now, but not valid nowadays. Okay, in our course I'll go more deeper on these points now. But people, why they say like what, PySpark is like what, someone having a mindset like what, Python is very easy to learn. That's the reason like what, I can also go. That is also one reason for them. Yeah, some question.
Kalyan,
Yeah,
basically,
please.
I'm using Edu Synapse as a platform for the data analytics. So we have a
Okay.
Scala language to write the code. So will
Okay.
this course help me?
Yeah, we are going towards that statement, sir. Okay. Yeah, I'm just giving you the what modules and what kind of variations are there. Okay, your
Yeah,
answer will be there in a few minutes. Yeah, fine. Okay, so now till here what I explained is like what, importance of the programming, whatever the Java, Scala, Python are these programming language now. Now suppose someone is interested like what, I'm not looking on this programming is my primary goal. I know SQL, I'm a database developer now, I know SQL, I want to utilize in a SQL now all these problems whatever I have it now, what extent I can solve it like what, SQL style only I want to do it now. They can also go with that, but with minimal, with minimal code of like what, writing in a Java or Scala or Python or R. So same syntax will be there, he will utilize the same syntax, but in between that syntax like what, he will go for like what, writing a SQL queries now. So that is also possible. If you are not interested to doing more coding part like what, you have an alternative Spark is providing is like what, SQL. Because of this reason, because of this reason like what, most of the people like what started adopting the Spark now. Because if you ask like what, write in a code means, people will might think like what, I'm not a coder now, I maybe know only this programming language like this. Okay, already Spark is saying you can utilize any programming language, but still writing a programming is like what, always lengthy only comparatively SQL. And Spark is clearly saying like what, you can start utilize the things in a SQL also from Spark 2 onwards. Please keep in mind, from Spark 2 onwards like what, as much as simplified by the Spark like what, writing the things in a SQL, but not 100% they are done no. But when it comes to Spark 3, almost they reach that stage now. Okay, almost in every library what they build on Spark core like what, Spark SQL is the primary point what we are talking about, streaming point of view, and also machine learning and graph theory point of view also, they started introducing the SQL features. Okay, Spark streaming is like what, mainly they started now, and now they are more concentrated on like what, Spark graphics and Spark machine learning. Okay, these two places like what, mlib having some inbuilt things are there, graphics is like what, completely external library is there now, maybe in Spark 4. That is also going to, right now their ongoing focus where exactly is like what, Spark SQL with the all libraries now. So once that is fulfilled, so what is the advantage? You will get it like what you can do everything in SQL style only. So that is more user friendly, and you can easily solve in any data analytics problems like what easily you can able to solve it like what SQL style. That's the goal of the Spark like what currently it is targeting now. Okay, so that's what like what regarding programming language with SQL, where SQL wise right now it stands now. Now, and coming to our course is like what how it is exactly organized now. Okay, so first we will be going to start with like what Scala. Okay, so I'll be going to give, if you don't have any Scala knowledge also not a problem now. So you no need to expertise in Scala and Python also to learn Spark now. Please keep in mind. Okay, you need to have some basic knowledge on like what Scala and Python. So I will be going to cover like what those two things as part of the course first. Then after that, learning our main goal is like what Spark. If you are learning the Spark, you learn through Scala or you learn through Python, you learn through Java, doesn't matter. Spark is the main thing like what they implemented in a functional style. There are certain functions or Spark is implemented. Okay, so that function you can utilize in Scala, Python or Java also. So that means learning a Spark means what? Learning the Spark functions. Those are called as generally operations. Spark operations, we call them as a Spark operation. These are two type of operations Spark supports now. One is called as a transformation, second one is called as a actions. Spark supports the two type of operations now. One is transformation, second one is actions. So I know Spark when you can say like what, if you know these two type of operations, if you know Spark transformations, Spark actions now, then you can say I know Spark. Why? Because any problem you can able to solve using like what Spark with these two operations only. So you want to learn those operations in a Scala or Python, not a problem. Okay, if you have any programming wise like what basic knowledge is there, you can able to learn these operations. That's the reason I'm saying like what first I will be going to give you the class on the Scala and Python basics, what is required to learn Spark now, what is required to learn Spark. So I'm not saying like what like a complete Java course like what Scala course, Python course, we are not going now. So what is required to learn Spark now. Okay, so that much knowledge is sufficient for us to continue, because you will be writing a Spark code in a basic flavor of like what Scala and Python SQL style now. Hope all are clear on that statement. Let me give some example to get an idea on what I said now. Okay, so this is one problem. Almost everyone knows this problem now. Given a some input like this. Okay, so each word how many times occurred, each word how many times occurred you want to calculate, means we can calculate. That problem is called as a word count. Okay, given an input file, each word how many times occurred, each word count, that is called as a word count problem now. So the output of this input is like what, I will be 2 times, m will be 2 times, remaining all keywords are like what, one time is there. Already people might solve this problem when you're learning your Hadoop course now, but the same problem in Spark if you are doing it. Okay, so I'm just showing like what Spark with Scala code and as well as like what Spark with Python code now. You can look at, you don't see much difference between these two. Why? Because here you need to learn Spark operations only. Okay, this is just a syntax of writing the code in a Scala, writing the code in Python. So this is the syntax for like what, writing the code in a Scala style now. This is the syntax for writing a code in a Python now. Okay, so just let me take this example once, how I can translate my Scala code into a PySpark code now, just to get an idea now. Okay, in Scala we have a keyword called val. In Python we don't have that. First we need to remove that. Just I'm translating existing Scala code into PySpark code now. Okay, so this is Python wise. This is Scala wise. Okay, this is the first change now. Then the next one is like what, whatever you write here now. So this one is called as an operation. This is one 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 operation. All these operations are same in Scala and Python. There is no difference because these are Spark operations. These are Spark operations. So there won't be any difference. So what is the difference will come like what? In this operation, this is way of writing in a Scala. But you have to write in a Python style now. How to do it in Python style is there is a keyword called lambda. You need to use a keyword called lambda. This should be kept as like this. This is a way of writing in Scala. This is way of writing in Python. So I'll explain that one in the our basic Scala and Python code now. Now same thing here also. And same thing here also. Now my code is completed for like what, PySpark. This you can execute, it will work. This you can execute. So here just this translation is only you need to understand. Writing in a Java or Scala or Python. No. But what is common for Spark learning is like what? These things. These are called as what? Operations. These operations only your target now. So you want to utilize these operations, either learn with Scala, either learn with Python, also fine for you. If you're not interested to do like this also, same problem, you can do it in a SQL style also. There you will utilize the SQL functions. Is that everyone is clear that statement now? Okay, so people call this one as a PySpark code. People call this one as a Spark with Scala code now. So what is you need to learn is like what? Scala Spark functions. There are two operations now, transformations, action. I'm not talking about right now what is this each line is talking about no, but the intention is like what? You learn Spark with Scala or Spark with Python, not a problem. You need to, your target is to learn the Spark now. For that, one of the programming language is knowledge is required. Is that all are clear? That any question on that? Okay, so just you want to verify this now. You can also execute these things. So I had just started like what in my system. So this is PySpark running Spark with Python. So this is like what? Spark with Scala now. Okay, so right now I'm running like what? One terminal is like what? Python Scala with Spark now. Another terminal is like what? Python with the Spark now. In both the places like what? Whatever the code we written now, we can just execute and validate. Okay, I need to have this input now. Let me check first of all, am I have it or not? I don't have it. Let me create it. One second. There is some issue with this latest version wise. I'll do differently. So I have this file right now. I can continue executing. Oh, I kept the name is word code. This is my input. This is the output now. In output word count output scalar. Output is generating. So now the output is came here. So it has two files now. The data is split into two parts. Whatever the records, 3 records here and 5 records. Totally 8 records now. You can see 1, 2, 3, 4, 5, 6, 7, 8. These are the 8 records like what divided into two parts. And the same thing like what if you go for PySpark also same thing. Just only thing is like what the way of writing in a Python. If any spelling mistakes we did, it will show it in both the programming languages. So I kept as a word count Python. Let's see that folder. This is the folder. Its output is generating. Okay, here also same thing. But this is in a Python style. So this is what calling as a PySpark code. So it doesn't matter is it a Java or Scala or Python. So you have to keep your target is like what learning the Spark. So learning the Spark in one of the programming language is a way to learn Spark only. So that's what just keep in your mind now. Okay, is it a PySpark you have to learn or Spark with Scala you have to learn or Spark with Java? It's not. So that is like what depends on is a data engineer means he will utilize that, data scientist means will utilize that. So but our course is like what designed in a way is first covering the Scala and the Python basics. With that and I'll be going to talk about like what Spark with Scala, Spark with Python, but primarily explaining like what this operation. If I explain this operation like what doesn't matter, am I execute this in a Scala style, am I execute in a Python style, both output at the end will give that. You only need to understand what is this. That explanation is like what common for me if I go Spark with Scala or Spark with Python. So that's what like what is very important. I'll be going to convey things in that way. Is that clear to everyone now? Any question on this? Maybe someone previously asked the question. I think Thiru, you have some question. Is that answered or still you have something on top of that? Okay. What about others? Okay. So now coming to this course is like what as I said, first we start with the Scala and Python. Then after that, like what we go for the Spark core, and the Spark core is the heart of the Spark now. Okay, complete end-to-end in-depth we need to learn. So as part of the Spark core, what are the things will come like what? Learning these operations is the one thing. And the second thing is like what design aspect, how exactly Spark is implemented, knowing the internal architecture, everything. Then after that like what building as a Spark project. Okay, so how you will be writing your code is like what not in a terminal in real time. So whatever you learn right now here, okay, you just need to build in a project style now. Okay, that project like what you need to prepare a jar file or like what Python means .py file now. You just need to create that and you need to deploy it. You need to deploy it. When you are deploying it like what different flavor Spark supports now. Okay, local approach now with mesos approach, with yarn approach, there are different flavors it supports now. So what is the difference between these flavors now, and what kind of limitations are there now, memory management, how it is going to come? So those things will come into that deployment part. So once that is covered now, once that is covered, like what, then the next thing is like what, Spark SQL. So again in Spark SQL, like what, different things will come. The first thing is like what, the Spark inbuilt come with like what, the SQL flavor now, and those all we need to know. And also Spark SQL supports like what, integration with the other systems now. Okay, Spark SQL having integrations with other systems like Hive and Cassandra, MongoDB, Phoenix, like this, like what, there are different other systems like what having integration support is there now. So those type of things also we need to know. This is my previous batch notes now, I'm just showing it now. Okay, so the Spark SQL, like what, there are different flavors of integrations will be there now. So how exactly we need to deal with the different variety of the data, like what, text file, CSV file, are going with Hive, are going with HBase, Cassandra, MongoDB, or Phoenix, are connecting with like what, JDBC with this, or this technologies wise now. This is also like what, in this graphics some third party integration is there. This integration will take some time, mostly in Spark core only it will come as an inbuilt now right now, but still it supports. Now I'll be going to show like what, how we can able to do like what, graph X operation also with SQL style now. So those type of things like what will be covered in the Spark SQL now. So this is also completely in depth will be taken with integration now. So then after that, like what, we have the concept of like what, Spark streaming. So when it comes to Spark streaming, like what, so the primary system what industry using is like what, Kafka, and also in older days people use it to play with the Flume also. But now the latest version of the Spark, if you take it like what, Flume support is not there, only Kafka support only. So in which version what support is there, what kind of code it uses to write now, that details with the streaming concept now. Okay, how continuous data is coming it, like what, how to do it. There are two type of streamings will be there now. One is normal streaming, other one is like what, structured streaming. So structured streaming concept is like what, SQL style now. Okay, the Spark SQL, this Spark streaming what we are calling, this is called as a structured streaming. And before this Spark SQL with this one streaming is called as a normal streaming now. So that is also like what, so that is still there now. In future versions of the Spark, like what, they'll remove it now. So till that time you need to have a knowledge on the normal streaming, and as well as like what, ongoing thing is like what, structured streaming now. So that will be covered now. Till this part, like what, in depth will be taken. So which is exactly covered in the basic of this course is like what, Spark mlib and graphics. Because if I want to teach this mlib and graphics like what internally, means I need to first start like what, data science course now. So our goal of the Spark course is not data science now. People who already have that knowledge now, so they can gain like what, whatever I covered still Spark streaming, like what, with that knowledge, how exactly the basic examples which I'm going to cover theoretically, practically in mlib and graphics will get an idea. Because if I want to explain in depth now, first of all I need to cover the data science in depth now. That's not this course now. Okay, so those two libraries, like what, we will be going with like what, conceptually with practically only. But only thing is like what, complete in depth we cannot go. The reason is like what, you should expertise in the data science knowledge. So that is not our course now. Hope all are clear that. Okay, I'm not saying like what, today I'll cover it, tomorrow I'm not. That's not, because if I want to cover in depth of that one is like what, my duration of this Spark course should be like what, around 6 to 8 months now. So we can't be go that much duration for this. Okay, whatever the fee and what we are going to teach now, that's not valid exactly. Okay, and at the end finally you will be having like what, project execution now. One e-commerce use case like what, I'll be taking it, and that e-commerce use case like what, completely with MVC architecture now, model view controller now. So how exactly this model view controller with Spark exactly we can inbuild now, and where exactly a developer part of the Spark is like what playing a role now, how to change the things when you change it now, how things will be connected. All these things will be like what the project will be going to share as part of the course to you. So later if you want to do any enhancements on that project, you can. That way you will get a control on like what happening also. So that's what covered in the course now, with performance use cases and everything also will be there now. Hope that is clear. And how things will be go like what, this is what you can see it also. This is the notes which is prepared when class is teaching now. Okay, so this is the same way like what our class also will be driven and execute and will be shared now. This is the notes exactly in the class time taken notes now. Whenever we are discussing the class, that time taken notes is this. It will go like this only the course now. Okay. Yeah. Any doubts from anyone? Okay. If you don't have any questions, then we can hold the session now. So this session will be like what, morning 7 to 8:30 now. It's 1.5 hour session now. So after that, like what, I'll be having sometimes at 8:30 calls will be there. So that's the reason I can't extend 8:30 after now. So that's the reason I'll cut down by 8:30. And Saturday, Sunday, you will be having 2 to 3 hours now. So minimum like what, because in Spark like what, there are some bigger topics will be there. So those things maybe sometimes in 1.5 hour is not sufficient. No, those I need to take it in the weekend now. So that way like what, some large duration like what, 2 hours, some topics might require. So those will be like what, in weekend it will be taken. So and the recording session will be shared and that will be available for you 1 year. Yeah. All are good. Okay. Thanks. Thanks everyone then.